Now, proteins are made of amino acids. Amino acids are either indispensable, conditionally indispensable, or dispensable. So this is similar to what we talked about in biochem, where ones we cannot synthesize, which we call essential, are also known as indispensable. There are some that are conditionally indispensable, that are made from the indispensable amino acids. Please take a look at your notes as we have lists of them in there. So if we're low in like phenylalanine, it's an indispensable amino acid. We can't synthesize it. If we're not getting it in our diet, then tyrosine, which is conditionally indispensable, then becomes indispensable. The dispensable ones are the ones that we can synthesize. Okay, when it comes to nitrogen balance, we have our cellular amino acid pool. That input for that pool is going to come from diet and beverages, and then also from recycling, so cell recycling. Output's going to go urea and urine, and deamination is going to remove nitrogen. What's left over then is going to be the residue that we can use to make other dispensable or non-essential amino acids. Now we can either be in a positive nitrogen balance or negative nitrogen balance. Positive is when we're taking in more than what we're excreting, so this is during periods of growth, pregnancy, muscle building, or healing after an illness. Whereas negative nitrogen balance means that we're taking in less, we're excreting a lot more, or our requirement is much higher. So that could be like with burns, or maybe we're just sick and not eating much, or cancer metabolism, or starvation. Protein quality is measured in several different ways. The gold standard is called the Protein Digestibility Corrected Amino Acid Score, which takes into account digestibility. The other ones we have protein efficiency ratio, which just tells us how much weight we're gaining total per gram of protein that we're consuming, and this is important for kids that are eating foods between the ages of 0 and 1, so foods that are destined for infants. They have to provide the percent daily value, which is based off of the protein efficiency ratio. And then there's the biological value, which is used for foods that are from kids from 1 to 4 years. Where growth is going to be really important in those first 4 years of life. All the way over to the left, let's look at some of our functions of proteins. So fluid balance and pH. That's important, maintaining osmotic pressure. It's our last resort for energy. That's the last thing we really want to use it for. Tissue building is an important function of protein. Metabolism, all the enzymes that are involved with metabolism, and transport, all transport proteins. And then our immune system, our immunoglobulins are all proteins. So this is where we talked about food allergies. The gold standard for diagnosis of food allergies is the oral food challenge, which you can't do in practice. So instead, utilize the elimination diet. With the true elimination diet, just a reminder, we usually cut what you think is the trigger food out, so cut out one food at a time. Cut it out for 2 to 4 weeks, symptoms should go away. Add it back in through a challenge, symptoms should come back, and again, it should be about 2 to 4 weeks of adding it back in. And then you cut it out again, and symptoms should go away. So you have to have all 3 steps for a true elimination diet. We have our big 8 food allergens in the United States. The ones that are more likely to resolve in childhood, we have milk, soy, wheat, and eggs. And then the ones that are more likely to persist into adulthood and not resolve are peanuts and tree nuts, fish, and shellfish. With dietary protein, we do have an RDA of 0.8 grams per kilogram of body weight, and they provide 4 kilocalories per gram. Also with this, we can have complete proteins. Complete proteins contain all the essential amino acids, whereas we have incomplete proteins over here. Incomplete proteins mean they're missing at least one amino acid. Your legumes are more likely to be missing methionine. Corn is low in lysine and tryptophan. And then wheat and rice are both low in lysine. So with this, we combine these incomplete proteins to form complementary proteins. And then with protein deficiency, there was 2 types of protein deficiency. One was called kwashiorkor. That's getting plenty of energy, just not getting enough protein. This is where we have a lot of edema. And then the one where they look more emaciated is marasmus. So marasmus is protein energy malnutrition, so they're just not getting enough calories overall. And then last but not least, we have our vegetarian diets. The most nutritionally complete is the pesco-vegetarian, which includes fish. If dairy and eggs are included but no fish, it's called lacto-ovo. Lacto-ovo dietary patterns can still be low in zinc, iron, and omega-3s because of the lack of fish. If it's dairy only, it's called lacto, which they're going to be, again, still low in zinc, iron, and omega-3s. If it's eggs only, it's called ovo. If you're cutting out dairy, it's also going to include not only the zinc, iron, and omega-3s, but also it's going to be lower in calcium, riboflavin, and vitamin D. And then vegan and fruitarians are low in protein and everything else that's been listed previously.